Hello, Miss Thinker here, your daily source for mind-blowing facts, forgotten history, and powerful motivation. Have you ever wondered what it would be like to travel to the center of the sun? It's a journey no human could ever take, but today we're going on an imaginary expedition to the heart of our solar system. Strap in because we're about to dive into a world of unimaginable heat, pressure, and mind-bending physics. Our journey begins millions of kilometers from the sun's visible surface, in a region called the corona. You might recognize it as that ghostly halo you see during a total solar eclipse. Don't let its ethereal beauty fool you. The corona is unbelievably hot, reaching temperatures of over 1,000,000 degrees Celsius. That's way hotter than the surface below it. Scientists are still trying to figure out exactly why the corona is so superheated. It's a place of intense magnetic fields, constantly flinging out streams of charged particles known as the solar wind, which travels all the way to Earth and beyond. As we descend, we leave the wispy corona and enter the chromosphere. The name means sphere of color, and for good reason. During an eclipse, it briefly flashes as a reddish ring. This layer is a turbulent, chaotic place, about 2,000 kilometers thick. We'd see massive jets of superheated plasma called spicules shooting up like fiery geysers, some reaching thousands of kilometers in height. Prominences, giant looping arches of gas held in place by magnetic fields, would tower above us, sometimes for months at a time. The temperature here actually drops from the corona's extreme heat, down to a cooler 20,000 degrees Celsius near its base. Now, we're approaching the part of the sun we actually see from Earth, the photosphere. This is the sun's visible surface. It's not solid, of course, but a 500-kilometer thick layer of dense gas. The temperature here is about 5,500 degrees Celsius. Looking down, we'd see a bubbling, granular pattern like a pot of boiling water. Each of these granules is about the size of Texas and is the top of a convection cell, where hot plasma rises, cools, and then sinks back down. This is also where sunspots appear. These dark patches are cooler regions caused by intense magnetic activity that inhibits the flow of heat from below. They may look small from Earth, but many are larger than our entire planet. Our shields are working overtime as we plunge deeper past the photosphere and into the convection zone. This layer is enormous, making up about the outer 30% of the sun's interior. Imagine an ocean of boiling plasma 200,000 kilometers deep. Here, energy is transported by massive rolling currents of hot gas. Hot plasma from deeper within rises, releases its heat toward the surface, cools, and then sinks back down to get reheated. This constant churning is what drives the granulation we saw in the photosphere and plays a huge role in creating the sun's complex magnetic fields. The density and temperature are increasing rapidly as we descend through this turbulent sea of fire. After navigating the turbulent convection zone, we arrive at the radiative zone. The change is dramatic. The chaotic boiling stops and the environment becomes eerily calm in comparison, but the pressure and temperature are now immense. This zone makes up the bulk of the sun's interior, extending from about 25% of the way to the center all the way up to 70%. Here, energy isn't carried by moving plasma. Instead, it travels in the form of photons or particles of light. But this isn't a quick trip for the photons. The plasma is so dense here that a single photon generated in the core will get absorbed and re-emitted by atoms countless times. It zigzags on a random walk that can take, on average, over 100,000 years to finally reach the convection zone. That's right, the sunlight that warmed your face today began its journey out of the sun's core before modern humans even existed. As we travel deeper through this incredibly dense plasma, the temperature climbs from 2,000,000 degrees to about 7,000,000 degrees Celsius. The pressure is millions of tons greater than Earth's atmospheric pressure at sea level. Finally, we've reached our destination, the core. This is the powerhouse of the sun, the engine that drives our entire solar system. It's a relatively small region, only making up about a quarter of the sun's radius, but it contains nearly half of its mass. The conditions here are almost beyond comprehension. The temperature soars to 15,000,000 degrees Celsius, and the pressure is over 200 billion times that of Earth's atmosphere. The plasma is so compressed that it's more than 10 times denser than solid lead. It's in this extreme environment that the magic happens, nuclear fusion. Under this colossal pressure and heat, hydrogen nuclei smash together with such force that they fuse to form helium. This process, called the proton-proton chain reaction, releases an incredible amount of energy in the form of gamma rays and neutrinos. Every second, the sun's core converts about 600 million tons of hydrogen into helium. In the process, about 4 million tons of matter are converted directly into energy. As described by Einstein's famous equation, E equals mc, this is the energy that will eventually, after thousands of years, make its way to the surface and radiate out into space, providing the light and heat that makes life on Earth possible. We are, quite literally, floating in the furnace of the stars. Our journey back to the surface will be just as incredible, witnessing these layers in reverse. From the crushing, fusion-powered core through the photon-packed radiative zone into the boiling convection zone, past the visible photosphere through the colorful chromosphere, and finally emerging into the ghostly corona before heading back to the familiar, safe distance of Earth's orbit. This imaginary voyage gives us a profound appreciation for the star that anchors our solar system. The sun isn't just a static ball of light in the sky. It's a dynamic, layered, and incredibly complex object, governed by forces we're still striving to fully understand. Every ray of sunshine is the end of an ancient, epic journey. Thanks for joining us on this incredible expedition into the sun. If you enjoyed this cosmic deep dive, make sure to hit that like button and subscribe for more adventures through our amazing universe. Let us know in the comments what cosmic destination you'd like to visit next. See you in the next video.